Swayam Prabha. Digital India. Educated India.
Hello everyone. Now today we are going to start the second module, which is analytical approaches on sampling of textile material. Although we will be talking about the mainly sampling of textile material, but this sampling technique is in general, and we'll discuss specifically with the textile materials examples, textile characteristics of textile materials. And in this module, we'll first discuss the sampling, what is sampling, and different techniques used for sampling of textile materials like yarn, sliver and fiber. First, let us start with the sampling, and after that we'll try to understand the basic statistics, practical statistics which is being used for industry, in the industry for analyzing the data and taking the particular decision. So sampling is actually it's evaluating or estimating the attributes, that means different characteristics of entire system, entire product, okay, or the process, or different types of characteristics through the representative material. Basically, it's not possible to test entire population, and by testing the small quantity, small numbers, we should be able to provide required information. There may be some variation that we will try to see. Ideally we should get the correct result if we test the entire population. Suppose we have 10 item. If we want to know the mass of the 10 items, we can simply take the mass of each and every items. But mass is basically, it's a non-destructive type of characteristics. We just take mass and we are not going to destroy the material. We will be able to use this material. And 10 is not that huge quantity, and it's manageable. So, but on the other hand, if we have say 10 lakh specimens, 10 lakh bobbins, or 10 lakh yarn cones, in that case it will be very difficult to measure the individual cone, 10 lakh cone, because that will require time and effort. On the other hand, another problem we may face, so there will be some test where the test nature is destructive. Suppose we want to test the strength of this board, wooden board. So we have to destroy these things. We have to do the tensile testing or bending testing. Okay, some fracture will be there, which will result that it will not be, actually cannot use this board. Similarly, for textile material, if we test the material for, say, tensile strength, in that case, or maybe say yarn evenness, so we have to take out the yarn from the bobbin, and the yarns which we are taking out from the bobbin, that cannot be used. So we are destroying the material. So in that way, if we try to test entire sample, entire population, then we will be destroying the whole population. So which is not actually correct. So the basic objectives of sampling is that we have to take small representative specimen which will represent the entire population. So the main purpose is that time requirement for testing, as I have already mentioned, and destructive nature of many of the tests, not all the tests, but many of the tests which are destructive in nature. So like tear testing of fabric, which is destructive in nature. Even cloth shrinkage, for that shrinkage test we have to cut the specimen, so which is destructive in nature. So targeting the entire population is not practically feasible. So we have to go for the small proportion which will represent the entire population. So let us see the examples. Like we have to test only 100 gram of cotton, and we have got 10,000 kg of cotton. So that small quantity we have to take, that we can, that is, which will represent very small fraction of the material. So this much 100 gram waste is acceptable. But if we try to perform test on 10,000 kg, it's not acceptable. Another example is that suppose we have 20 tons of yarn. So it's not possible to test 20 tons of yarns. So we will take the random specimen, so say 10 randomly selected cones, say total 20 kg yarn, we will take the randomly selected cones and we will perform the test, so which is relatively smaller in proportion. But the sampling, if we take sample, we have to be very sure whether this small proportion is actually representing the entire population or not. For that we will discuss subsequently that how to be sure that our small proportion is actually representing the entire population. That population, when population is very large, it will be too costly. That we have already discussed, and time consuming to do the comprehensive analysis of all the items. Like we have say 10 lakh bobbins. So if we try to test, even if it is not destructive, as I have mentioned, if we try to take the mass per each bobbin, that also will be very time consuming, and that will indirectly or directly actually connected with the cost. So ring bobbin in a spinning mill, that I have already explained. So it will be too expensive for us to test all the bobbins. So the basic aim of sampling is that to produce an unbiased representative of whole population, which is very important. There should not be any biasness. The small specimen which should represent the entire population. So that's very important, and this is basically, for example, if we try to take the cotton fiber sampling from the bale, the proportion of different fibers, so fibers of different length, so maybe there will be different fibers of different maturity, different color mixed in a bale. So in the bale there may be a different proportion. You will find the fibers are of different characteristics. So one side it's a longer fiber, somewhere you will find the shorter fibers are there. So we have to be very careful in selecting the fibers from bale. So through sampling system, we should be very careful that fibers from each proportion or fibers of different length have got the equal chance of being selected. So now we can see from this diagram, this is one bale representing, say, cotton fiber. Within the bale, the cotton fibers are of, say, different length direction. So here length distribution is there. So in this zone some longer fibers are there. Here you have shorter fibers are there. And so if we take the longer fibers portion from the bale, that means we are selecting the fiber in biased way. Our idea should be that we select fibers from smaller length, longer length, medium length, so from different zones without any biasness. See, in doing this, we may sometimes result of selecting fibers from longer or shorter length. That actually is it's a statistical error will be there, that we will discuss subsequently, but there should not be any biasness as far as the procedure is concerned. So the factors which are governing the sampling are, we are discussing only the textile material. Only for textile material we are discussing. It's a form of material. So there are different sampling procedure. If we want to test the fiber, our sampling technique will be entirely different than when we have yarn sample or fabric sampling. If we want to test fabric strength, the sampling method will be entirely different than if we want to test the yarn strength or fiber strength. And also, say whether the fibers are in loose form or the fibers are from the sliver or yarn. So these are the different forms available. Suppose we even within the yarn, if we have say yarn in cone form or yarn in bobbin form, that's ring bobbin, the sampling technique will be different. And also, suppose we want to test a yarn strength. Yarn strength from the cone, yarn cone, and yarn strength of yarn from the fabric, the sampling technique will be different. So the sampling method is governed by the form of material. Then it's a nature of the material of same form. Like, let us take example, we are taking the fiber. If we take say cotton fiber, if we want to test cotton fiber say diameter, which is actually linear density, cotton fiber fineness and wool fiber fineness. So cotton comes in the bale form, cotton bale if you take the cotton, main characteristics is that we from the bale, if we open the bale, we can take out the individual fiber. The taking the tuft or some quantity of fiber from cotton bale, it's easy. But as far as wool is concerned, if we see the wool bale is very compact and fibers are actually stored, packed in very compact form, and due to presence of grease in the wool contains typically 30 to 40% grease. So this due to the grease, wool becomes very compact. Even if you open the bale, to take the fiber from the bale, it's very easy, very difficult. It's basically fiber will be in a compact block form, and from there if we want to take the fiber from the center, it's a totally impossible without proper sampling. So manually it's taking, if we try to take like cotton fiber, it's very difficult. So nature of material here, difference is that the cotton material is that cotton, if you open the bale initially it is compactly packed, then it will become open and you can simply take out the fiber with a little effort. But if we take the wool is very compact, so it's impossible to take normally fiber from the take out the fiber from the wool bale. So for that, the different sampling techniques are used. In cotton, we take the manually, we just open the bale and we take out the fibers. But for wool, as the wool is very compact form, so wool fiber sampling is done basically using core sampling technique. There is a technique we will discuss. Our basic idea here is to take the small specimen. Now, third governing factor is that amount of material available. That I have already mentioned. If we have say 10 bobbins available, our sampling method will be entirely different than if we have say 10 lakh bobbins available. So, amount of materials availability, depending on that, we change our sampling technique. Nature of test. So, if we try to test say high volume instrument for cotton, our sampling technique will be different from the technique which is comb shorter fiber length. If we try to test say fiber length for in the comb shorter, then sampling technique will be different. So depending on the nature of test, suppose if we try to test the yarn for twist test, the sampling technique will be different from the strength testing. So from yarn from cone, we want to test for twist and we want to test for strength, the sampling technique will be different. So nature of test actually governs the sampling method. Type of test instruments available. So suppose I have a Lee tester available, okay, and another case I have say UTM. In both the case we can test the strength. And if I have CRT type Lee tester, the pendulum type Lee tester, so we need a Lee form, yarn in Lee form. Ultimately we will get the yarn strength. But in UTM, we can test both yarn in the single form or maybe in a Lee form. So test instrument will govern the sampling technique. Information required. It's very important. What do you need? Do you need to measure the diameter of fiber or length of fiber? So that will govern the sampling method. As I have already mentioned, that core sampling technique used for wool fiber. Core sampling technique is used for wool fiber where the fibers are cut through the coring tube. So by coring tube, the fibers are cut to a small length, and this specimen which we get from the wool bale by core sampling technique are of small pieces of fiber. So if you want to test the fiber length by core sampling technique, it's not possible. But if we want to test diameter of fiber or moisture content of fiber, so we can use core sampling technique. But for wool, if we want to measure the fiber length, in that case, so we have to first remove the grease, then separate the fiber, then only we can test the fiber length. Degree of accuracy required. Suppose we want the rough estimation of fiber, say yarn linear density. So yarn linear density, yarn count, English count or text. I want to know what is the rough estimate. What I will do, from say large number of cone, I will pick 2 or 3 cone randomly, and I will test the yarn linear density, which will give me a rough idea about what is the linear density. But if I want to know the linear density accurately or with a greater accuracy, in that case I have to change my sampling method. I have to use different statistical technique, and that I will discuss. First thing is that here I cannot use 2 or 3 bobbins. I have to use large number of bobbins. So total sampling method is changed. Ideally, I will get correct result, correct value of linear density if I test entire population, which is not feasible as I have discussed. So degree of accuracy will govern the sampling method. So after sampling method, now we have to actually do the sampling. So governing factor we have understood. Now we will discuss the type of sampling. So the sampling is broadly classified into 2 types. One is statistical sampling, another is non-statistical sampling. So here we should not get confused that statistical sampling is it means that you have to use the proper statistics. It's not that. Here in statistical sampling we actually mean that we use some structured procedure, and non-statistical sampling is there is no structured procedure of sampling. That's a broad meaning. So statistical sampling again subdivided into 4 types. What are those? Random sampling. So here it's nothing to do with the statistics, okay, but there will be structured procedure. Systematic sampling, stratified sampling. We'll discuss each and every point in detail. Systematic sampling, then stratified sampling, that is strata, which means a group, subgrouping, and then cluster sampling. These are the 4 types of statistical sampling. Then non-statistical sampling are of 2 types. One is haphazard sampling and next is judgmental sampling. Haphazard sampling by by the term we mean that here it's evident that we will not follow any standard procedure. It's a haphazardly we will do. And judgmental sampling means we will use our judgment. So that I will discuss each and every point. Now first let us see the random sampling. Random sampling means what? We will take the sample from the population randomly without any biasness. We will not introduce any biasness. Okay? And where each and every component or each and every element has got equal opportunity of being selected. That's the random sampling. Suppose I have in a box, I have 1,000 balls. Okay? So I'll devise the method in such a fashion that the probability of selecting, probability of getting each and every ball selected will be same. There is no biasness. Like I can select the specimen from the top of the box, which will actually incorporate biasness. But if I actually make a system where the probability of selecting the specimen from top, middle, from side, from bottom are equal, then we will call it as random sampling. So let us see an example. We want to take 20 bobbins. 20 bobbins from a population of 1,000. 1 to 1,000 bobbins. So we have to select the 20 bobbins. So how do you do? If we suppose there are 1,000 bobbins, so we have to devise one method. There are several methods we can actually, but we are incorporate. But ultimately, we have to develop one method where we can take out 20 bobbins out of 1,000 bobbins. What we can do? We can make a slip of say 1,000 paper in a box. So in a box we will make a small paper slip, and where we will write the number from say 1, 2, 3 up to 1,000. Small. Then what we will do? We can take out the 20 such papers from this box randomly, and accordingly we will mark the bobbins 1, 2, 3, 4, 5, 6 like 1,000. And suppose first we have selected 31. So we will pick the bobbin with 31 number. Next say 47 or say 21. So accordingly we will go on picking the bobbin. So this random sampling is done with or without replacement. What does it mean? Suppose I am taking one sample, 20 sample I have taken first. The next sample if I want to take, so here if I out of 1000 bobbin, if I take 20 sample, 20 bobbin taken out, I have tested, and remaining 980 sample. So without replacement means next sample if I want to take second sample, I will test on 980 bobbins. I will take the sample from remaining 980 bobbins. But with replacement means I will send it back, and again it becomes 1000 bobbins, and then again I will test. There may be possibility one of or few of this will again be selected, doesn't matter, because we are not giving, we are actually leaving everything on chance. We are not actually giving imparting any biasness. So if we do without replacement, then an item is not returned to the population, as I have discussed, after its selection. Okay, this can only occur once in the sample. So what we have discussed, suppose here we have stored the small paper slip from 1 to 1000 in this box, and we are taking out this, and as it's a 1000 is 4-digit function, so we'll take the, so we are taking the 0. If we take 0, if we have first digit is 0, then we have to go take the 4 such specimen. If first digit is not 0, then we have to take maximum 3 specimen, 3 such slip, because we have 1000 bobbins are there. So first 0 is selected, we have taken the first slip which is 0, then 3, then 8, then 2. So what it comes, 382 number bobbin, we have marked the bobbin, so 382 number bobbin is selected, 382 number specimen is selected. Now the best thing here is that 382 number is selected, there is no biasness, no one has control over that, only it's a chance, by chance. So this is this is actually done to avoid any biasness, it's entirely random fashion. So another way, the main problem with this type of sampling is that it will again be very time consuming. Here you have to prepare the slip and take out, and instead of this, nowadays what it's done in random number generation is also possible. Through the software one can generate, you give the range from 1 to 1000, I would like to generate the random number. So random number generation is also possible. And suppose you just generate, you generate say 382 number, immediately you generate. Next time you generate say 5. So you keep on taking all this specimen. So that's also possible. This is the random sampling, and random sampling is basically used In subsequent processes also, random sampling is basic process. I'll discuss. Next is the systematic sampling. It's another statistical sampling method. Here you are actually trying to make one specific system. What does it mean? Suppose I have one to 1,000 bobbins are there, 1,000 specimen. In random sampling, what we have done? We have taken randomly. Like randomly, there may be a possibility, say 20 specimen we have to take. 20 specimen, there is a possibility you are picking when the randomly you are generating, it may be from 1 to 20 may also come. Or maybe say 10 specimen comes from the say first 20 bobbins. There is no problem as long as it's a random. There's no problem. But let us take another example. Suppose that you have say 10 ring frames. Each ring frame has got say 400 spindle. So 10 ring frames, 4,000 spindles. So you have say 4,000 spindles. What you have to 1, 2, 400, 1, like up to 4,000. So this 400 means first ring frame. Then you have second ring frame, 800. In this way, you have say 10 ring frames. Now, in random sampling, there is a possibility out of 4,000, what you may get land up, you are taking most of the samples from number 1. There is a chance. So to eliminate these things, the systematic sample where you have say 1,000 bobbins are there, 1,000 specimens are 1,000 in the population, 1,000 samples are there. So these 1,000 items, and what we want to do, you want to test say 20 bobbins. From out of 1,000 bobbins, you are trying to take the specimen of 20 bobbins. What you do, 1,000 divided by 20, that is 50 is a block. 50 is a block. Okay, and which is this block is known as the N. So if we do say 1, 2, 3, 1,000, so here 50, then 51, 100, like this. So we have divided 20. So this is block 1. This one is block 2. In this way, it will continue. Now, what we have to do, in earlier case there is a problem. In block 1 we may select all the samples or majority of the samples. But here to avoid this, out of one block we will be selecting one sample specimen which is kth element of this block. So let us say kth element K is 11. 11 is the K. That means here, if it is K is 11, then what first specimen from block 1 will be 11. Then second specimen from block 2 will be 61. Then in this way, third will be 101. In this way it will continue. So ultimately we will get 20 specimen which will actually distributed over the entire population. Okay, so this system is followed in many of the sampling techniques where large number of items are there. Okay, so this is actually example is given here. So if you want to take, say here, out of 1000 bobbins, if you want to take 100, so here 10 is the 100 bobbins you want to take, so 10 is a block. Earlier I have mentioned it's as n, so you can say K is the 10 in a block. So from the 10th, every 10th we are supposed we want to take, so 6th element here, 6th element we have to take. So 100 bobbins we have to take, so every 6th if you want to take, so then 6th, 16th, 26th, in this way it is. So we have already formed without looking at the population. So there, so today you are taking the 6th, tomorrow next time you take the 5th, or like that. So we can keep on changing so that there is no biasness. So the example here it's given as I have shown here earlier. So out of say 1000 you want to take say 20 bobbins. So set 1 to 50, set 2 51 to 100, like that, and in this 11th, 61st, in this way you can go on and you will be taking the 20 specimen. So this is the system. So in spinning mill, this type of system is followed, where you have already marked the number is marked in ring frame, in a particular ring frame, in a series, and then you follow. You want to take 20 out of that, depending on your number of bobbins, number of spindles, you can frame this systematic sampling. Okay, it's very easy for ring frame or maybe different winding and all. So that one thing one must say, that systematic sample to ensure the original population list has not been ordered. So you cannot order the population. That means when you are collecting the material, so there should not be any particular order. So suppose all the poor varieties of materials are in a particular place and all. So there should not be any order. So which will be non-random. So specific, it should be random order. So this we have already discussed here. 14th sample, 14th element from the out 20th, that block we can take. Next is the stratified sampling. Stratified sampling is widely used in spinning industry for collecting or sampling the bobbins. It's very practical and convenient one. Strata means subgroup within the population. So a ring frame, in the ring frame, suppose a mill producing yarn of say 30 any yarn. It's producing 30 any yarn. And this yarn is produced in 4 different types of ring frame. Make 1 ring frame, make 2 ring frame, make 3, 4. 4 different types of components are there. Make 1, make 2, make 3, make 4. From 4 different suppliers they have got. And this 30 count they are producing for a particular consignment, particular buyer. And what you have to do, we have to take care that we are taking the specimen from all the different makes. Okay? And suppose in ring frame 1 we are selecting the bobbins. Ring frame 2 will be selecting. So this stratified sampling we will be doing. I will be using that stratified. We will have some logic. But after that, when we have selected ring frame 1, we have to take the sample from ring frame 1. Here we have to use the random or systematic sampling. Within the stratified, we have to either use the random, so it can pick the ring frame, say 10 ring frame bobbin from ring frame 1, 5 from ring frame 2, again 10 from ring frame make 3. But if while taking 10, we must follow the either random or systematic. Again we have to go there back. Now example of stratified is that suppose we have to select as per our statistical requirement, we have to take the 40 ring bobbin from 4 different makes. 40. So what is that? 10% of the ring frames are of make 1. 60% are make 2, 20% make 3, and 5% are of make 4. So 4 different types of ring frames are there. So our strata, that is subgroup, is ring frame. We are subgrouping. We are although all the ring frames are producing 30 NE, but within that 30 NE, we are actually subgrouping that. But after the yarn is made, we will mix everything. But before that, when yarn is being produced, we are making it a strata, a subgroup. So 40 ring bobbins are there. Our sample is that 40 ring bobbins. So this 40, that means 10% of this 40 will be taken from the make 1, that is 4. Okay? 60% of the bobbins will be taken 24. Okay? 25% will be taken from make 3, and 5% will be taken from make 4. Okay. So if we add, so from ring frame from make 1, we will be taking 4. So in this way we will be, and when we are taking 4 or 24 or 10, so say from make 2 we are taking 24 sample. So how will you take? So this 24 specimen we will be taking using the either the random sampling or systematic sampling. Okay. So here in stratified, what we are ensuring that we are not eliminating or avoiding any ring frame. We are taking all the ring frames into all the ring yarns from all the ring frames into our specimen. See, here this is actual population. In actual population, when you are producing, let us see assume that they are running at same speed, same RPM. So make 1 10% of the year. Make 2, this is make 1, make 2, make 3. Accordingly, this is the population. And when we are trying to take the specimen, smaller specimen, for this is the population, smaller specimen, we will be taking in the same proportion. But another method, so the same proportion we are taking. So as I have mentioned, 4 bobbins, 24 bobbins, 10 and 2. This is small. Another approach is there. We can take equal number from every strata, even if the number is less, number of the ring frame are less, so equal proportion. Can also sample an equal number of items from each subgroup. Okay. So this is the stratified sampling. And another method is that cluster sampling or block sampling. So cluster sampling is little bit different, which may not be a homogeneous method. It may be heterogeneous. Like this we have discussed. This is the homogeneous. So we can actually, it is representing every corner, like stratified, systematic, random. They are actually representing total population. But the cluster sampling, maybe it sometimes may be completely heterogeneous, but it has got practical application. Question may be asked, when if it is non-homogeneous, why do we use this cluster sampling? Now let us give one example. In the industry, if we see that the textile industry, like a spinning mill, it actually runs throughout the day and night, continuously, 24 hours. and it is actually typically say 3 shifts. 3 shifts. And if we see, the lab is normally open in a daytime. Okay. And night time, it's not that economical to keep the entire staff at the night time and also in the daytime. So what it is assumed that if the production is going on continuous basis, then the daytime whatever production will be there, the similar production will be there in the night time. Those specimens are taken normally in the daytime and tested in the daytime, morning shift or day shift. In the night shift, although some testings are done typically, but with not that intense testing. So that means there may be some heterogeneous. We are actually taking a particular cluster, but it actually it is workable. Similarly, suppose we have 4 different ring frames, and so ring frame 1, 2, they don't actually create any problem. They are new. There is no problem. From our basic actually experience, we know that 1 or 2 is running perfectly. 3 and 4 sometimes creates problem. So then in that case, the sampling is taken from 3 and 4 and to check this thing, whether the count variation is there. So this is actually we are clustering this thing. Or maybe from 4 different make, we are taking a specimen from only 1 make. And always, whenever you are cluster, after that your random sampling has to be taken from that. So example is that here example is given, a ring spinning mill, 30 ring frames are running. Testing yarn linear density might use a cluster of randomly selected 4 of those ring frames are representative test. Then randomly. So what he is doing? Okay, suppose this is an industry where 30 ring frames are there. 1, 2, 3, 4, 30 ring frames are there. These ring frames are of same make, so running perfectly. Now what he is doing, okay, today I will be testing these 4 ring frames. Next day I will be testing another 4, like that. So in that way, he is actually making the cluster. That's also workable. So what happened here? Cluster sampling can tell that about this 4 ring frame, or maybe in the day shift, but it may not give the right picture of the entire population. So you cannot always generalize that it's a entire population, but it's a simple way of doing. You just take the randomly 4 ring frame and then do it. So randomly 4 ring frames or ring frames from a particular make, that we can do. And then comes the non-statistical sampling. These are actually very quick method. So here information about the entire population cannot be extrapolated. You cannot extrapolate, but you can get some idea. So you will get some useful information. So haphazard and judgmental. So haphazard means you just go to the ring frame shed, you pick randomly from anywhere. Haphazard, from the top, from the side. There is no such a written rule is there. So lab technician, he goes to the shop floor, and then he thought that I'll just pick randomly after by closing my eyes, or he may take from the top. So whatever way he feels, he can do. The idea is that suppose one buyer has come, he doesn't have time to do the random sampling and all this thing. He doesn't have time that. So he will pick some bobbin from somewhere and try to test for some strength, and it's called haphazard. That it's not always the rejectable. It's not. It will give some information. He could grab a bobbin close to him, or from the top of the box. So wherever, so it's usually quicker method, small sample size then. So you can take say 2 bobbins and test it. So you will get fair idea about the total population. It's a non-statistical. Okay, you cannot generalize. That's the disadvantage. You cannot generalize. Okay, I am taking a yarn bobbin and test. I cannot generalize that it will be entire population, but I'll get some idea. And last one is that judgmental sampling. You use your own judgment. Like in a ring frame shed, one ring frame is actually creating vibration. It is giving some poor result, and you have checked the vibration level, or the maintenance people have set the machine correct. Now after that you want to test. So you go there and select that defective machine and take the sample using your judgment. What are you trying to do? I want to see that whether this quality is giving a better quality or not. So there is no statistics, and also what you can do, you can go to the sample like a supplier. If you ask him what to take the sample from his plant, he goes and he is trying to take the best quality, best looking sample. That means he will do. Suppose one buyer has gone, he is trying to take the sample which is a damaged sample, damaged bobbin. The judgmental sampling is totally biased sampling. But you are trying to prove something. Okay. This example is that the lab technician might select a bobbin with better appearance. There is no randomness. Why better appearance? Because at the back of his mind, he thought that it may result better quality. I want to prove it's a better quality. So he is using his judgment. Okay. So I'll stop here now. So we will continue this discussion in the next class. Thank you.